Hey guys, welcome to the Level 1 MCAT paper from 2021. This is day 2 of this particular paper. The best way to watch this video is to pause the video at the start of each question and then try the question out by yourself, and then unpause the video just to see how I go about answering the question. I'll also mention what you guys need to do for achieve merit and excellence. So without further ado, let's get started. Okay, so with question 1, what we've got here is we've got the given, the perimeter of the shape is 35 centimeters, find the value of y. So basically what it means is that these 1, 2, 3, 4 lengths, they all add up to 35, and we've got to try and figure out what y is. So what we're going to be doing is we're going to write down all of our sides. So we've got y plus 5. It doesn't matter which side you start from, as long as you get those 4 sides in. That's the most important thing. So y plus 2 plus y plus 3y minus 2, and all of this is equal to 35. So at this point, what we want to do is we want to collect all of our like terms. So we've got 3, 4, 5, 6y, and then we've got 5 plus 2 minus 2 is 5. So we're going to have 6y plus 5 equals 35. The next thing is get rid of the positive 5. So when it goes to the other side, it will become minus 5. So 35 take away 5 is going to be 30. And what we've got here is y is equal to 30 divided by 6. And so we're going to end up with y is equal to 5. Now this question is worth an achieved, I believe. Let me just double check. Yes, it is worth an achieved. And I just want to show you guys the answer schedule real quickly. If I can load it, that is it going to load up? Yep, there we go. So you have for an achieved, you've actually got to form and solve the linear equation. So you've got to write some sort of linear equation, right? You can't just guess and check the answer. Because if you guess and check the answer, I think you're allowed to do one guess and check, so they might allow you for that. But you know, for a full grade of achieved, you do need to form the linear equation, and actually solve it as well. Oh, we're going to the wrong screen. There we go. Cool. That is question 1A. Okay, so with question 1B, what we've got here is solve the inequality. We've got 2 brackets on both sides, and I guess the first thing you really want to be doing is expanding the brackets. So we've got, you know, look, to be honest, I don't know what you guys use, whether you use FOIL, I'm sure there's like 100 other methods out there. Pick the one that you're comfortable with, and as long as you get to the quadratic simplified, that's all that matters, all right? So in this case, I've got 4x and 2x, which is 8x squared minus 4x plus 6x minus 3. Is greater than or equal to 8x squared plus x minus 16x minus 2. Now at this point, I'd actually say, you know, whenever you're dealing with a quadratic, just simplify it, man. Like, you know, those middle terms, you got to simplify it. Like, otherwise you get pinged for not simplifying and stuff like that. So I'm going to simplify this fairly early, so I'm not going to kind of like tinker with this. So what do we got? Plus 2x minus 3 is greater than or equal to 8x squared minus 15x minus 2. All right, so with that in mind, what I'm going to be doing next is I've got 8x squared on both sides, so I can actually get rid of them, because if I bring 8x squared to the right hand side, it's going to become minus and it's going to become 0. But you know what, just for old time's sake, I'm just going to write it down here. So 8x squared, talking about this 8x squared, when I bring it over here, it's going to be negative, and what I've got here is 2x minus 3 is greater than or equal to minus 15x minus 2. Now 8x squared take away 8x squared is 0, and of course I want to bring all the x's to one side, take all the numbers to the right hand side. So the first one I'm going to be moving is the negative 15x, which is now going to become positive 15x. And what I've got here is greater than or equal to minus 2. But of course, I've also have this minus 3 on this side. And when I switch it over to the right-hand side, it is going to become positive 3. Okay, so with that in mind, what I've got is 17x is greater than or equal to positive 1. and then I can say that x is greater than or equal to 1 divided by 17. Okay, so grades wise for this question, interestingly enough, this is a merit question, right? Like you get to the last line right there, you're looking at a merit grade. For an achieved, I'm going to show you guys the marking schedule here. So basically for achieved, doing that first line, so that's that first line there, and as long as you simplify the inside term, then you get like an achieved straight away for and it says either, right? So you could actually do the first one or the second one, which is why it's really important when you're working with quadratic equations that you want to actually simplify the inside, the x terms mainly, because sometimes that actually ends up being just enough to get you an achieved. All right, so even though they've got 4 bullet points there, you only need like that 1 bullet point to get an achieved. So if you get that first thing right there, then you're going to get an achieved for it, which is not bad. I mean, it's just like a straightforward expanding question, right? And I think they even are correct inequality find, so they're even accepting like less than, even though your answer is actually greater than or equal to, sorry, greater than, not less than, greater than or equal to. So merit grade, that's what this one is worth. We'll actually head back to the next question. Okay, so with question C, what we've got here is we've actually got 2 rectangles, right? So A and B, blah, 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 whatever. We've been given the perimeter. Perimeter for the first one for A is 20 centimeters. And then rectangle B is 26 centimeters. All right, so what we've got here is, I mean, you've got 2 unknowns. Because they're actually saying find the length and width of rectangle A and B. Really, we've got 2 unknowns. We've got G, we've got H. We don't know what it is. Whenever we have 2 unknowns, we straight away know that we're going to be doing simultaneous equations. Okay, so let's go to this. We've got perimeter. Perimeter means it's got to cover both, basically the border here. I'm just going to put them in different colors so you can see what's happening. So that is A right now, right? So with A, rectangle A, it adds up to 20, but we've actually got 2 lots of 4H, remember? So we've got 4H here as well because that's the green colored one. So 4H and 4H is 8H, plus we've got 3G at the bottom and we've got 3G at the top. So we add it together and we're going to get 6G, which equals to 20. So just to kind of highlight that the green part is worth 8H and the yellow part is worth 6G. All right, so that's for the first first rectangle. The second rectangle, we've got 5H, which means the top is going to be 5H. And we've got 4G for the right-hand side, which means the left-hand side is also going to be 4G. So we've got 4G and 5H. So our second rectangle here is going to be 8G plus 10H equals 26. So just to iterate again, so the 8G is the purple part and the blue part is the 10H, which is 5H plus 5H. All right, so we've got 2 equations here. Form both equations for perimeter, must have combined like terms. Yeah, okay, so guess what? If you write this, just these 2 equations right here, you are automatically going to get an achieved grade here. All right, that's just part of the forming equations. So we're going to leave that and then we're going to go around to actually solving these 2 questions. So a really kind of a good idea is to actually write with simultaneous equations. You want to write the letters in the appropriate order. So what do I mean by that? If you look at the first equation, we've actually got 8H here. We've got 8G here. So I'm just going to rewrite that first equation with G in the front. So this is going to become 6G plus 8H equals to 20. All right, so now that I've got my 2 equations, I'm going to kind of stack them on top of each other. So I've got 8G plus 10H equals 26. And then at the bottom here, I've got 6G plus 8H equals 20. All right, now what I'm going to do here is I'm going to look at these numbers. Remember, we don't actually have a calculator. Because we don't have a calculator, we've got to kind of be quite, I wouldn't say like tactical is tactical is the word I'm looking for in terms of doing the least amount of work, right? We don't want to eliminate h here, and the reason is why. If we want to eliminate h, we have to actually multiply the top equation by 8, and we've got to multiply the bottom equation by 10, and that's like that's a lot of work, right? And I don't want to be, I mean, doing that, because it's like 26 times 8, you know, I can make some real simple mistakes. But instead, I'm going to get rid of g here. All right, with g, I know that I have to actually take the entire equation, because I'm looking at 8 and 6 right now. So let's have a look. So this is the 8 and 6. I want to try and eliminate g. And I know between 8 and 6, the lowest common multiple is 24. So what I'm going to do is I am going to multiply this entire equation by 3. As for the bottom one, I'm going to take this entire equation and multiply it by 4, because 6 times 4 is 24 and 8 times 3 is 24, and I know I can get rid of it. Okay, so because I'm doing this, I am actually going to kind of write this further down here, and I've got to take each of these elements and I've got to multiply it by 3. So 8 times 3 is 24, so it's 24g. Then I got 10 times 3, which is 30h, and 26 times 3. All right, now you're thinking, do 25 times 3. 25 times 3 is 75, and then you got that 1 extra times 3, so you're going to get 78. All right, as for the bottom equation, we've got 6 times 4, which is, so I'm going to do this, 6 times 4, 8 times 4, and 20 times 4. So 6 times 4 is 24g. 8 times 4 is 32h. And then 20 times 4 is equal to 80. Now, again, you can kind of be tactical about how you actually stack this equation. Like, I'm sitting there going, it's like, oh, I don't really want to put that 78 minus 80 because I'm not really good with negative numbers and, you know, whatnot. Flip it. So what do I mean by that? We're going to rewrite these two equations with the bottom one on the top, 24g plus 32h equals 80. And then we're going to write 24g plus 30h equals 78. Now, we actually want to do the top equation minus the bottom equation. And look, if you guys know a method that you're confident with, just stick by it. In this case, what I tend to do is, like, I kind of go, well, I want to do the top equation minus the bottom equation. So you can do this multiple ways, but I just kind of just go to the top here and I just switch all the symbols around. Because if I go minus, that is no longer plus, that is minus there. So I'm just subtracting that top equation, take away the bottom equation. So when I do that, I am going to get 24g, take away 24g is just 0. 32h, take away 30h is 2h. 80 take away 78 is 2. So what I've got here is 2h is equal to 2. If 2h equals to 2, then I know that h is equal to 1. With that in mind, I actually need to go work out what g is. So I need to pick one of those equations. I could actually pick the rectangle A or rectangle B. Doesn't really matter. I'm going to go with rectangle A. So I've got 6g plus 8h equals to 20. And because I've discovered that h is equal to 1, I'm going to substitute h equals to 1 here, which means I'm going to get 6g plus 8 times 1. I'm just going to put that here, which means I'm going to get 6g plus 8 is equal to 20. Rearrange it. So I've got 6g equals 20, take away 8, and I'm going to get 6g is equal to 12, and g is equal to 12 divided by 6. So therefore, I can say that g is equal to 2. Now, I've not finished the question, because if you go back and look at the question actually says, find the length and width of rectangle A and B. All right, so you've got to actually go back and substitute G and H. So what I'll do is I'm just going to copy rectangle A here. So that was A, where it was 3G and 4H. Then we had rectangle B, which was 4G and 5H. Now, because G is equal to 2, I can go 3 times 2 for the base here, which is 6. 4 times 2, which equals to 8. So that was G. And H is equal to 1. So I can say 4 times 1 is equal to 4. 5 times 1 equals to 5. So I can actually say rectangle A is 6 by 4 centimeters. So you could kind of write it like this. 6 centimeters by 4 centimeters. And then rectangle B is 5 centimeters by 8 centimeters. Pretty long question here, but like it's not overcomplicated, right? Like, so this question does end up being an excellence question. So and the thing is, with the excellence part, you do have to get all of it at the end, like the correct dimensions. Mainly you've got to go and say A is 6 by 4 and B is 5 by 8. If you find correctly combines the equations in one variable, consistently finds dimensions, you're going to get them. Like, let me just show you guys what I'm doing here. I'm just going to go back to the answer schedule. So as you can see, if you get the final answer, you're going to get the final answer here. You're going to get an excellence. So that's what that T means, right? But if they say correctly combines the equations in one variable, I'm thinking somewhere around here, you could probably get a merit as well. Consistently finds dimension. So let's say you make a mistake somewhere and then you kind of work your answer and you got the wrong answer, but you know, you kind of had the right working, you can still get a merit for that. All right, so bit of an open question in terms of what you can get for achieved in merit, but for that excellence, you've got to get the dimensions of A and B. So with these types of questions, guys, the main thing that you need to do is you actually need to bring the denominator to be the same number. All right, if you don't bring the denominator to be the same number, you can't really combine the fractions. So hint one, what I always do is I kind of like space these fractions out quite a bit, and I'll show you guys why. And actually, no, in this case you don't need to, but like maybe up to here. Now, in this particular case, we've got 4 and 3 in the denominator, right? Because we've got 4 and 3 in the denominator, we know the lowest common multiple is 12. So what that means is I need to multiply the denominator here by 3 and also the numerator here by 3, and make sure I'm putting a little bracket around it just to make things easier. Likewise, for this one, I've got to multiply the denominator by 4 and also the numerator by 4. Okay? This is pretty much step one. You've got to do this. If you don't do this, I can guarantee, there's a very high chance, actually, not guarantee, there's a very high chance you're going to end up making a mistake, because you've got to combine the two fractions into one before you can actually go on to solve this question, right? So what do we got? In the numerator, we've got 3 times y plus 3 divided by 12 minus 4 times 2y minus 3 divided by 12 is equal to 3. Now, because now we can actually combine the two fractions together, because 12 is a common denominator for both of these fractions. So we rewrite this as 3 bracket y plus 3 minus 4 bracket 2y minus 3. All of that is over 12. I'm having some issues with my... Yeah, there we go, it's back. Over 12 is equal to 3. So at this point, we can actually get rid of the 12 to the other side. So we move it across to the right-hand side, it becomes multiplied. So I'm going to do that at the start. So it will become 3 times 12. As for the brackets here, I'm going to actually expand the brackets. I've got 3 times y, 3 times 3, negative 4 times 2y, and negative 4 times negative 3. This is going to give me 3y plus 9 minus 8y plus 12. So combining your like terms, you've actually got minus 5y plus 21 is equal to 12 times 3 is 36. Gonna keep going. Minus 5y is equal to 36. Take away 21 because it was positive 21 on this side. What do we have here? Negative 5y is equal to 15. And then Sam, if you're still around, you've got y is equal to 15 divided by -5. And with that in mind, we can actually say y is equal to -3. So grades wise, we are looking at a merit grade for finding the answer of y equals -3. Correct arrangement for numerator does not need to be simplified. Correct arrangement for both numerator and denominator. Okay, I'm going to show you guys the answer schedule because I'm trying to interpret this. Correct arrangement for both numerator and denominator does not need to be simplified. So does that mean it's line 1, line 2? Arrangement. So maybe line 1 it is. So if you get up to line 1, you're looking at an achieved. I mean, that's my interpretation of it. If I'm wrong, I apologize, but I guess that's somewhere around here is going to get you an achieved grade. So as I said, this type of question tends to pop up every now and then, even at level 2. So yeah, it's just something that's worth remembering, and just keep practicing, guys. Okay, so with question E, what do we've got? We've got a flower bed, blah, 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 9 meters by 6. It's in the center of the fence backyard, leaving border, blah, blah, blah. The area of the whole backyard is doubled the area of the plot. Okay, all right. Basically, what we've got here is we've actually got 2 rectangles. All right, we've got the inside flower bed rectangle, and then we've got the outside rectangle. So the first thing I'm going to do is I am going to kind of, what am I going to do? Let's do this. I'm going to have this yellow one here. All right, and then we've got the green rectangle here. So I guess the first thing we kind of need to understand is that the yellow rectangle's area, which we can actually work out because it's 9 times 6, it's right there. So yellow area's rectangle, sorry, yellow rectangle right there, yellow rectangle, is we've got 9 and 6. So area of the yellow rectangle is 9 times 6, which equals to 54, which means the green rectangle, which we don't know the dimensions for, but we do know the area is actually double that of the flower bed. So it's double of the yellow. All right, we actually getting this from right here. Double the area of the flower bed. So if that's the case, we now know that this is 2 times 54, which equals to 108. Okay, cool. What are we trying to figure out? We're trying to figure out what x is. Now, to figure out what x is, we kind of need the dimensions of the green rectangle, all right? So if you think about it like this, it says x and x, and what am I going to do? I'm going to do it like this, and have a look at this, okay? So I'm going to look at the base of this green rectangle first. I know that, and I'm going to have to use a different set of colors so you can see it. This distance right here is actually equal to 9. All right, so let's actually write that down. So that's 9 meters. Now the next part is this x here, and there's an x here, which is going to be the extension of the green rectangle. So what we have then is we've got x here and x here. So we've got x, we've got 9, we've got another x. Combine it together, you're going to actually have 2x plus 9 as the base of your green rectangle. So we're going to go back up here and we're going to put this as 2x plus 9. Now we kind of need to repeat that same process for the height of the rectangle. So if you look at the height of the rectangle, we know that this part here is worth 6 meters. All right, if this is worth 6 meters, we're going to kind of like draw this again. We know that this part here is also worth 6 meters. So we're going to put 6 meters there. The next thing is we're going to have this x here is what the border is. That's this part right here. And we've got another x, which happens to be here, matches up to the height of the green rectangle. So in this case, we've got x here, x here. What do we've got? We've actually got 2x plus 6. So 2x plus 6 happens to be the height. We have rectangles. We have the base and height of the green rectangle. We have the area of the green rectangle, which is 108. So we can actually say area of green rectangle is equal to base times height, which equals 2x plus 9 multiplied by 2x plus 6. We also know that this is actually worth 108. So we can kind of go 108 equals to this. Now, just getting to here, I know it seems like a lot of work, right? But it's just kind of playing around with your dimensions and trying to get that right kind of equation. Once you do that, you are going to get an achieved straight away here. All right, now next thing, consistently, blah, 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 blah. Okay, so what do? We've got a quadratic. Expand it, rearrange, factorize, solve, and that's pretty much what we're doing here. So we're going to start expanding this quadratic here. So we've got first, outs, ins, last. So what we've got here is 108 is equal to 4x squared plus 12x plus 18x plus 54. 9 times 6, 54. Okay. So then we've got 4x squared plus 30x plus 54. Now I'm going to bring this 108 to the right-hand side, which means it's going to become minus 108, which means there's nothing on that left-hand side, which is going to be 0. So I've got 0 is equal to 4x squared plus 30x minus 54. Now, you could try and factorize this from this point onwards, but one of the things that I noticed straight away is that all these numbers can be divided by 2. So I'm going to take 2 out as a common factor, and I've got 2x squared plus 15x minus 27 is equal to 0. So at this point, I can forget about the 2, because 0 divided by 2 is 0. But, you know, I know sometimes people kind of go, oh, what happened to the 2? So here we go, 0 divided by 2. I'm just going to put that extra line there. We've got 2x squared plus 15x minus 27. So 0 divided by 2 is just 0. We've got 2x squared plus 15x minus 27. At this point, people have asked me, hey, can I actually use quadratic formula for this? Go ahead, all right? Because even though some people have not learned quadratic formula, if you actually remember it and you are comfortable using it, then you can use it. Because as long as you've got the working right here, and then you get to the solution, which is the next part, you can get to the factorization solution. It doesn't matter which method you use. I mean, as long as you can show that you've actually understood what you've done so far, and then kind of work through it. So again, you know, there's lots of ways of doing this. I've seen some people doing like crisscross things and do some magic and it works out. I'm not saying my method is the correct method or anything like that. This is something that works for me. You know, if it works for you, great. Otherwise, you've got to try and figure out how to solve these types of questions with those myriad of strategies that are available. So we've got 2x squared plus 15x minus 27. So what I do is I go 2 times, the way I do it, I take those 2 outside numbers and I multiply them together, which gives me minus 54. Once I get that, I am pretty much looking for, so what is this? Where did I get that 2 times 74? Just to give you an idea. So that's the 2 times negative 27 there to give negative 54. What I want though is I'm actually looking for 2 numbers that multiply to negative 54 but adds up to plus 15. And this is where you kind of have to be kind of comfortable with like those common kind of numbers, right? Now I know for a fact in this case 18 times 3 is 54, which means negative 18 times negative 3 tend to work. So what I do is I replace 18 and negative 3, 18 and negative 3 adds up to 15, so it works out. So I'm going to rewrite this as 2x squared plus 18x minus 3x minus 27 is equal to 0. So all I've done here is I've replaced 15 with 18 minus 3, which I got, oh man, you can't see that color, can you? Hang on, give me a second, I'm just going to get rid of that. Green is terrible. Is pink going to work? Yeah, much better. So 15x, I've actually got that 18x minus 3x from this 18 and negative 3. Once I do that, the next part is I've got to kind of separate them into almost like 2 parts. So I've got 2x squared plus 18x minus 3x minus 27 is equal to 0. So in here, the common factor is 2x. Here I got x plus 9. And on these two terms, I've got minus 3 as a common factor. So it's x plus 9 equals to 0. Now, x plus 9 itself is a common factor. Then I've got 2x minus 3 as the other common factor. So to kind of reiterate, the 2x is from here, and the minus 3 is from there. We're not finished yet because we still need to figure out what x is. So we've got x plus 9 is equal to 0, or 2x minus 3 is equal to 0. Now x plus 9, in this case, it just becomes 0 minus 9, so x is actually equal to negative 9. And in this case, we've got 2x is equal to positive 3, because 0 plus 3 is just 3. And then x is equal to 3 divided by 2. Now, remember that we are actually looking at a garden where the border is increased by x, which means it has to be a positive number. It can't be a negative number. So you've got to kind of say a statement, something like, therefore, x is equal to 3 over 2, as x can't be negative. I get a feeling my dog's going to go out for a big bark very soon. Where is he? Yep, there he goes. Hang on, I'll be right back. So, grades-wise, there he goes. Give us a second, I'm just going to go grab him. Cool. Finished chasing the cats. What do we got? X can't be negative, we got that. This is worth an excellence, guys. Correct positive solution and so on. Where were we? We're up to here. So we've got x can't be negative. Yeah, we've done all of that. So that's going to be excellence right there. For a merit, simplification to a quadratic equation can get you a merit, which is up to there. And of course, if you actually get a wrong answer from any of this, you could also get a merit for it. So pretty much, yeah, that's pretty much it for this question. So even though it's a long question, it's just a matter of like kind of breaking down the question as to those little parts and then slowly kind of working your way to it. Yeah. Okay, so question 1, what we've got here is what's the area of the square with the side of length 4y plus 7. So we've got a square here. Just going to draw a rough little shape here. And we've got the side, which is 4y plus 7. Now remember, this is a square, which means all four sides are equal to each other. So I also know that the height of this square is going to be 4y plus 7. Now we're asked to work out what the area is. Now the area for a square or any kind of rectangle shape is like base times height. So we've got 4y plus 7 multiplied by 4y plus 7. Now at this point you might decide to do FOIL. I don't know, like people have like so many different ways of doing this. And as I say in every video, just do the one that's actually comfortable for you. And as long as you get to the final answer and simplify that final answer, you're pretty much good to go. So what do I mean by simplification? Like some people do this. So 4y and 4y is 16y squared. And then they got 28y, another 28y plus 49. Now, if you leave your answer like this, you're not going to get an achieved. You need to simplify it because you need to collect your like terms, which is 28y and 28y. And putting them together, you're going to get 16y squared plus 56y plus 49. And you can, if you want to, you can actually write down what ABC is. But really, it's just asking you for in the form. And because it's asking you for in the form, you can actually leave your question like this, which it will get you an achieved. So with question B, as I said before, what you want to be doing is you want to rewrite 16 as 2 to the power of 4. So we're going to rewrite this as 2 to the power of 2y multiplied by 2 to the power of 2y minus 12 equals 16 is written as 2 to the power of 4. Now, before we get rid of the base, we've got to combine the powers on the left-hand side. Because remember, if you have something like this, 2 to the power of a times 2 to the power of b, this is equal to 2 to the power of a plus b. And so I'm going to do that here and replace this with 2y plus 2y minus 12 is equal to 2 to the power of 4. Once I do that, I can get rid of the two bases because it's on both sides you've got base 2. So I can rewrite this as now 2y plus 2y minus 12 equals to 4. I'm going to combine my like terms, so 2y and 2y is 4y. So 4y minus 12 is equal to 4. 4y is equal to 4, and of course minus 12 when it comes to this side is going to become plus 12. So we've got 4y equals to 16, and y is equal to 16 divided by 4, which means we are going to get y is equal to 4. So grades wise for this question, as I mentioned to you guys, where was the grades? So correct value of y found is going to get you a merit. So this part right here is going to get you a merit. Consistently forming a linear equation from a base of 2. So I would say if you get up to this line here, you could also get achieved. Simplification of the powers of 2 on the left hand side gets you an achieved. So if you get this right here, you could also get an achieved for that. So as you guys can see, you know, it is a merit question, but a couple of places where you could actually get that achieved grade from. Okay, so with question C, what we've got is a lovely fraction question, all right? And with these types of questions, like I said before, you want to make sure that you attempt the question as far as you can. Just because, you know, it's one of those questions where you can pick up some achieved and merit even if you don't solve the question. All right, so we've got to actually make the denominator the same. And one of the things that I tend to do is I tend to kind of like rewrite this, but just with a little bit of extra space. So I do something like this. Let's go 3y plus 4 and equals 2y plus 1. All right, so the reason why I did this is because I actually can see that the denominator here is y minus 4. And the denominator here is y plus 4. So what do I want to do is I want to have the two denominators to be the same, which means on that left-hand fraction, I need to multiply by y plus 4 and y plus 4 in the numerator. And as for the right-hand side fraction, I got to multiply by y minus 4 in the numerator and denominator. So that's what I'm going to do. So I've got, just going to put this in a bracket, y plus 4 and y plus 4. And then on this side, I've got y minus 4 and y minus 4. And that's part of the reason why I write this with a little bit of space. Now, if you look at the numerator then, in the numerator, that's the top line, you've got 3y plus 4 minus 3y minus 4. And because the two denominators are the same, I can actually put the two denominators together now. And of course, don't forget the everything on the other side of the equal sign. So at this point, what I can do is I can actually expand the brackets. So I've got to expand these. I've got to expand this. So I got a whole lot of expanding to do. So I've got 3y plus 12 minus 3y plus 12. All that is over y squared minus 4y plus 4y minus 16 equals 2 times y plus 1. Okay, so I'm going to simplify the numerator and denominator. So in this case, I'm going to get 24 over y squared minus 16 equals 2 over y plus 1. Hope I've got a left enough gap there. I think I have. So now I've got this, I can actually cross multiply, and I'm going to get 24 multiplied by y plus 1 equals 2 multiplied by y squared minus 16. So once again, I've got to expand the brackets. I've got 24y plus 24 equals 2y squared minus 32. Let's see if I still got space. Now I'm going to rearrange. I'm going to write this up here. So we've got 24y plus 24 equals 2y squared minus 32. So at this point, I'm going to bring everything together so I can form a nice quadratic. So I'm going to get 0 equals 2y squared minus 32. And of course, I've got minus 24y minus 24. So simplifying this, I'm going to get 2y squared minus 24y minus 56. And at this point, I can see that 2 is a common factor, so I can take 2 out as a common factor. I'm going to get y squared minus 12y minus 28. And then, of course, I can take the 2 to the other side. Then it'll become 0 divided by 2. Now, 0 divided by 2 is just 0. So I'm going to get y squared minus 12y minus 28 equals to 0. Okay, I got a nice little quadratic equation here. And so I'm going to factorize it. So I've got y. I'm looking for two numbers that multiply to negative 28 and add up to minus 12. So I've got minus 14 and plus 2. So here I can say that y minus 14 equals to 0, or y plus 2 equals to 0. So in the first instance, I've got y equals to 14, and in the second instance, I've got y equals to negative 2. So grades-wise, getting both of these solutions is going to get you an excellence. As for the merit, I want to show you guys what you can actually do for merit. So for an award of merit, correctly arrange and remove denominators. So I would say probably this line here is going to get you a merit. You make a mistake here, but you get like the right answer. You make a mistake here and then you get the incorrect answer, but you know, if you had fixed that right, you would have got it right. Kind of like the consistent solutions. That's what they mean by that. So you could have made a mistake here, but the rest of your problem was correct. You could still get a merit. Combining into a single fraction, numerator must be simplified. Combining into a single fraction. Oh, wow, that's a merit. So this part right here could also be a merit. Numerator must be simplified. So that means if I go back to my working, we are looking at here to get a merit. Yeah, an achieved correct factorization of so if you make like a mistake, let's go back here. Correctly rearrange this equation to remove denominator. Oh, that's really weird. Trying to figure out how this would actually look like. To be honest, I don't know how you'd rearrange it so that that would work. Because if you've done the previous step, you're already going to get a merit. And of course, achieved correct arrangement. Yep. So that's the left-hand side, unsimplified expression. So just doing that first line is going to get you and achieved there. So as you guys can see, like lots and lots of opportunities to get grades like achieved merit. But of course, when you've solved the final two solutions, you are actually going to get an excellence. Okay, so with question D, what we've got here is simplify as far as possible. So we've got to factorize the numerator and factorize the denominator. Now the denominator is really lovely, nice and simple to kind of factorize, but the numerator is one of those painful quadratic things, right? So I'm going to kind of do that separately here. So I've got 3x squared minus 2x minus 8, and we basically need to bring it into this format where it has two brackets. Now, you might have your own way of doing this, guys, and it's absolutely fine, all right? You can even guess and check if you want to. That's also fine as well. So like, you know, whether you do the algorithm that I choose, whether you choose quadratic formula, whether you choose to guess and check, it doesn't matter. What matters is that you are going to actually end up with that final two brackets. Now, the way I've been kind of tinkering around with it is I take these two numbers, I'll multiply them, and I'm going to get negative 24. And the next step is I'm looking for two numbers that multiply to negative 24 and add up to minus 2. Now, I know for in this case, it's going to be minus 6 and 4, minus 6 and 4. So what I'm going to do is I'm going to rewrite that 3x squared minus 2x minus 8 as 3x squared minus 6x plus 4x minus 8. So all I've done here is this going to work? Yeah. So I've taken this minus 6 and 4 and I've actually put that in here. The next part is, of course, I need to split them up into two parts. and I need to factorize them. So in my first case, I've got 3x as a common factor, so I'm going to get x minus 2. And in the second case, I've got 4 as a common factor, and I've also got x minus 2. So what this is going to factorize into is x minus 2 and 3x plus 4. By the way, the 3x is from here, and the 4, positive 4, is from there. Okay, so I've factorized it, which means I can go to the top here and rewrite this as 3x plus 4 bracket x minus 2 divided by, now in the denominator I can see that 3 is a common factor, so I'm going to take it out and I'm going to get x squared minus 4. And of course x squared minus 4 we can factorize to x plus, hang on, let me just do this top line first. And in the bottom line I've got x plus 2 and x minus 2. So at this rate, I can see that x minus 2 is a common factor in the numerator and the denominator. I get rid of it. And then I can rewrite this as 3x plus 4 over 3x plus 2. Now, with this question, that is all that there is. You don't need to solve it because you've kind of simplified it as far as possible. That's it. You can't do any further. Guess what? This is what a merit. Now, numerator or denominator fully factorized is going to get you an achieved. So you could get an achieved if you get the numerator right or the denominator right. And here's a tip for you guys. Whenever you do this question, particularly this simplify fraction question, right? You're always going to get one bracket that you're going to cancel out. All right. If you didn't cancel out one bracket after that, like second line, then you know you've done something wrong. So in your head, guys, you guys have to actually kind of register that, I've got this quadratic over another quadratic, which means I'm going to get two brackets and one of those brackets is going to cancel out. And as long as you can get to that, you're looking at a very, very straightforward, easy merit question here. Okay, so with question E, what we have got here is painting some straight lines, total length. Right, so we've actually got, so this is one line, that's 1x, got 2x, 3x, and then this right here is y, this right here is also going to be y. Now, so the total length she has for painting these lines, these 5 colored lines, is 16. So we've got our first equation, which is 3x plus 2y is equal to 16. All right, so that's the first one. The next one is if the shaded area is 10 meters squared, find the possible values of x. Now, the area of this shape is base times height. Now, the base is equal to x and the height is equal to y. So we can actually say, and we know that area is 10, so we can say 10 is equal to x times y. What we've got here is just an ugly quadratic, that's all. All right, because let's think about it. We've got area is equal to 10, we've got x and y, but on the other side we've got the perimeter of like the another equation set up which gives the lines. So we're going to have to rearrange this, right? So we're going to rewrite this as 2y is equal to 16 minus 3x, and then we're going to write down y is equal to 16 minus 3x divided by 2. Now, the reason I did all of this is because what I'm going to do is I'm going to take this y, which equals to 16 minus 3x over 2, and I'm going to replace it with this y in the area. So it's kind of like a simultaneous equations, but not really. It's more like one equation that's positive, like with addition, and the other one is with area, right? So, but we're substituting. That's what we're doing. So we're going to rewrite this as 10 equals x multiplied by 16 minus 3x over 2. So all I've done here is I've actually gotten rid of that y and I've replaced it with 16 minus 3x over 2. So now what I'm going to do is I'm going to kind of manipulate this so I can make this into a nice quadratic equation. So first thing I'm going to have is I'm going to put this bracket around 16 minus 3x, and I'm going to get rid of the 2. And how am I going to get rid of this? I'm going to do one extra step here. So I'm going to rewrite this as 10 equals x multiplied by 16 minus 3x divided by 2. Now, I'm going to get rid of the 2 and bring it over to the other side, which is the left-hand side, where it's going to become 2 times 10 equals x times 16 minus 3x. So what do I have here is I've actually got 20 equals, I'm going to expand the brackets now. So I've got x times 16 and x times minus 3x, which gives me 16x minus 3x squared. Rearranging this, bring all the 3x squared to this side, which will become positive 3x squared. 16x when it comes to this side becomes minus 16x plus 20 equals to 0. So at this point, what I need to do is I need to factorize and I need to figure out what x is. So I've got 3x squared minus 16x plus 20 is equal to 0. So I'm going to do that thing that I did in the previous question. And again, like I said to you guys, if you are comfortable in kind of knowing, yep, I know how to get from this quadratic into putting it into two brackets, by guess and check, it doesn't matter. Just go for it. All right. But I'm going to kind of work with that algorithm that I've been playing around with. So I've got positive 20 times 3 is 60. And I'm looking for something that adds to minus 16. So I'm looking for two numbers that multiply to 60 and they add up to minus 16. So kind of clue, gives a nice clue, negative 10 and negative 6. And also kind of looking at this, what I might actually do is I'm going to split this up in this way. Like, see, you could write it like this, right? 3x squared plus, minus 10x minus 6x plus 20 equals to 0. But when I look at these numbers, like 3 and 10, factorizing it is a bit, but then 3x squared and 6x. So I'm going to rewrite this, right? I'm going to rewrite it like this. 3x squared minus 6x minus 10x plus 20 equals to 0. Because when I do this, factorizing this by parts becomes a little bit easier. So I can actually rewrite this now as 3x bracket x minus 2. And then here, negative 10 bracket x minus 2 is equal to 0. So what do I've got here? I've got x minus 2 in one bracket. And in the other bracket, I'm going to get 3x minus 10 equals to 0. By the way, 3x is from here. The minus 10 is from there. Now I've got two of these brackets equal to 0. I've got to solve them. So I've got x minus 2 is equal to 0. Or 3x minus 10 is equal to 0. So in my first case, I've got x is equal to positive 2. And in my second case, my negative 10, when it goes to the other side, it becomes positive 10. Then I've got x is equal to 10 over 3. So my two answers, what is the question actually asking? The question's asking, find the possible values of x, which I've actually worked out. So I'm going to write down, therefore, x is equal to 2 or 10 over 3. So grades wise, finding both possible values of x gets you an excellence. Forms an equation in one variable gets you a merit. Forms an equation in one variable. So would that mean right here? Because that's an equation in one variable. I would almost say that's actually worth a merit. Consistently solves for the equation. So let's say you make a mistake and you get the wrong answers, but then you do all the steps correct. You could get a merit. This part right here, the very first line, is going to get you an achieved. And there's a few other things that you could potentially do. So consistently factorize. So these are like, you do this and then you make like little mistakes in your numbers, but then you show the methodology, which means you can still get an achieved for it. So as you can see, like these types of questions, don't leave them empty, guys. Even if you start off with the wrong like equation at the beginning, if you kind of work it through and they can still see that, oh, this person actually knows how to factorize. This person knows how to do quadratic expansion. So we could still potentially give a grade for that. So keep that in mind and make sure you attempt as much of this question as possible. All right, so what do we got for question 3A? We've got a nice little substitution question here. So just all we got to do is just replace x and y in the main equation. So we've got x equals to 2. We're going to replace that. And we've got y equals -3. Where are we going to do this? Replace y with that. Just be careful, guys. It is y squared. So it's actually going to be -3 squared minus 4 times 2 multiplied by -3. -3 squared is +9. So we've actually got 3 times 9. And then here we've got 4 times, -4 times 2 is -8. -8 times -3 is +24. So we're going to get 27 plus 24, which equals to 51. By the way, I checked the answer schedule. Correct solution is 51, but interestingly enough, they actually say that if you actually accept 27 plus 24 as an answer, that's really quite interesting, because that actually means that, you know, even if you stop right here, you're probably going to get an achieved. But really, you know, you want to try and kind of finish that question off so that you can actually get the achieved. So that's achieved right there for that question 3A. We will go to question 3B, and I'll try and answer some questions on the side here on the chat. Okay, so with question 2B, what we've got here is a quadratic, and this particular quadratic, you know, it's telling you that you've got two solutions, A and B. It's also telling you that A being greater than B, and then it's asking what is the value of A minus B. So we've got to solve the quadratic equation first, and then after we solve the quadratic equation, we get our two solutions, and then we've got to just go the big one minus the small one, and we should be good to go. All right, so we've got 5 equals 3x squared, take away 14x. I'm going to make the left hand side 0, so this will become 3x squared minus 14x minus 5. So at this point, guys, I always say this, you know, if you have like a quadratic equation and you know if you're comfortable with quadratic formula, then yeah, go ahead, do it. If you're comfortable with guessing and checking, go ahead, do that too. I know I do this weird looking algorithm thing, and if you understand it, great. If you don't understand it, then I guess you got to find out one method that's going to actually work for you. So the way I go about this is I have a look at these two numbers. 3 times minus 5 is minus 15. So basically I'm looking for two numbers that multiplied in minus 15 but add up to minus 14. Now in this case we're lucky because we can kind of see that this is going to be minus 15 and positive 1. So all I'm going to do is I'm going to rearrange this quadratic equation where instead of negative 14x, I'm actually going to write down minus 15x plus 1x minus 5. Really, I should have had that minus 5 in blue, because where did I get this 15 and 1? I actually got it from here. So I'm replacing the minus 14 with the negative 15 and positive 1. Once I do that, then I kind of separate these two terms, and then what I've got is I look for common factors. So in the first side I've got 3x as a common factor, so this would become x minus 5, and in the second side of that green part of the line, the right hand side of it, I've got 1 as a common factor, and I'm going to get x minus 5. So what I then have is I've actually got 3x plus 1 times x minus 5, because x minus 5 is a common factor between both of them. The 3x comes from there and the 1 goes to there, and then of course x minus 5 is a common factor. So with that in mind, I've got my two solutions now. 3x plus 1 is equal to 0, or x minus 5 is equal to 0. So in this case I've got 3x is equal to minus 1. Then I can say that x is equal to minus 1 over 3. So that's my first solution. And my second solution is taking the negative 5 to the other side, I get positive 5. So I've actually got two solutions here. right? So that's 5 and negative third. Now it actually tells you that A is being greater than B. So in this case, we can actually say A is equal to 5 and B is equal to negative 1/3. And of course, it's asking for A minus B. So because it's asking for A minus B, the value for it, we're going to go 5 minus negative third. And of course, this is the same thing as saying 5 plus 1/3. And so we can just write it as 5 1/3 as a mixed fraction. Now, be careful. You know, sometimes people see 1/3 and they write it as 0.33 and then kind of round it. So we want to leave the answer as accurate as possible. So that's why we leave the answer as a fraction in this case. Now, grades wise, looking at this question, which part do you get achieved? Factorizing the quadratic can get you an achieved. So getting up to this line is going to get you an achieved. For merit, both correct values of x found. So this is going to be merit. And then excellence is here. Now let's say you actually make a mistake somewhere here. Let's say you make a mistake here with the minus, right? Unfortunately, that's still only going to get you a merit. So yeah, so this question, you know, I think it's just once you get the idea of the quadratic and you rearrange and you get the two solutions, it's pretty straightforward excellence question compared to some of the more challenging ones that I've seen before. Alright guys, so with question 3c, what we've got is find the values v and w, blah blah blah, we'll make it true given both in v and w are positive numbers. Alright, so we've actually got, you know, it's just a quadratic equation really, because what we've got here is 3x plus v squared equals 9x squared plus wx plus 16. Now, what you can do is you can actually expand the left hand side, and that's probably the first way I would probably start doing this. I'd go 3x plus v multiplied by 3x plus v. Now this is equal to 9x squared plus wx plus 16. So at this point, what I need to do is I need to expand the brackets on the left hand side. Whatever way you choose, you know, whichever one way you're comfortable with, it doesn't matter. As long as you get to that final quadratic simplified, that's all that matters. So in this case, I've actually got 9x squared plus 3xv plus another 3xv plus v squared equals 9x squared plus wx plus 16. Okay, so with that in mind, I've got 9x squared plus 6xv plus v squared equals 9x squared plus wx plus 16. So at this point, guys, it's all about just matching your coefficients of x squared. So if you look at this, coefficient of x squared is 9 and 9, so that matches, that's not a problem. Then if we look at the constant, which is the number without any x to it, on the left hand side is v squared, on the right hand side it's 16. So that's our first clue. So we can actually say that v squared is equal to 16. Therefore, v is equal to square root of 16, which is going to give us 4. Now notice, normally when you take a square root of a number, you're going to get positive and negative. But because in the question itself, they actually say that v and w are positive numbers. And because v and w are positive numbers, we know that v is equal to positive 4. The next thing that we need to figure out is w itself. So w is the coefficient of x, but on this side, coefficient of x is actually 6v. So what we've got then is we've actually got 6v is equal to w. We figured out what v is, which is 4. And so we can say that w is equal to 24. And once again, I don't think we need to worry about it being positive or negative. Well, no, I'm talking about the w. The w is positive because we've got a positive 4. That's basically it for this question, guys. You've got to find both of these values to get merit. So you need w and, so this is and for a merit. For an achieved, you either this or this, that's going to be an OR. Also, you could get an achieved here as well, potentially in this line. Just doing this part, you could also get an achieved as well. Yeah, pretty much that's a straightforward merit question. Just need to understand that you kind of need to expand the equation to kind of match it up. All right, so with question 3D here, as I was saying to the live audience here, like this question was actually kind of like an excellence question at level 2 back in the day, if I remember correctly. Yeah, the paper I was looking at was 2014. Yeah, 2014 level 2 paper. But anyway, how do we go about doing this question? Now look, if you do get a question like this, you have to understand, right? When you look at this question, you're like, oh, g to the power of 4, man, I got no idea how to do that. Yeah, you're right. You know, you probably don't. But what you can do is you can actually get rid of the g squared. And one of the things I'd say is, if you ever get a question like a quadratic, but the powers are like different, but then have a look at the powers. Notice how these two powers, the 4 is actually double that of 2. So that's kind of giving you a clue that you're actually dealing with a quadratic. So what we're going to do is we're going to do a little substitution. We are going to put x is equal to g squared. Now if we put x equals to g squared, then we can say that x squared would then become g squared squared, which equals g to the power of 4. And I hope you guys can see the little substitution that I'm about to make. Because what I'm going to do is I'm going to replace x with g squared, and I'm going to replace g to the power of 4 with x squared. And when I do this, I'm going to get a very straightforward, simple quadratic. All right, now we know how to solve this, because this one is like x minus 4 equals to 0, and we've got, therefore, x minus 4 is equal to 0, and we can say that x is equal to positive 4. However, we need to figure out what g is. Because we know that g squared is equal to x, we can say that g squared is equal to 4, which means g is equal to square root of 4. Really important that we actually say g is equal to square root of 4, but we've got to put that plus or minus there. All right, now remember in the previous couple of questions when we did the square root of 4, and we said that actually we don't need to worry about the negative, because in that case it actually said the v was positive. In this case, when we take a square root of a number, we always have to consider the positive and negative for it. Yeah, by the way, this question is an excellence question. You get both of those answers right, you're looking at an excellence grade. Correct factorization of the equation to quadratic factors. I'm going to show you guys the answer schedule, because they actually did it with g squared itself, and we did it with a bit of a substitution there, and that's okay. So here they talk about recognizing the g for g squared within a quadratic factor. So that's an achieved. So if you manage to substitute it, you get an achieved. Correct factorization into quadratic factors, consistent solution. So again, remember, like if you just put down g equals to 2, that's only one correct solution. So that's why it's really important to put that plus or minus to get your full grade. Now, as you guys could see, there was a lot of options for merit. Correct factorization could get you a merit. Getting this could get you a merit. Achieved is probably, I would say, even this could get you an achieved, because that's going with the factorization process. But yeah, so it's not a challenging excellence question, even though on first looks it looks challenging. It's just these little hints that as you guys do more exam papers, you kind of will start seeing like, oh, I can actually do that. Oh yeah, I remember doing that, so I can substitute this. But yeah, that's pretty much it for this question. Alright, so for the final question, question 3E, we've got a lovely rearranging question. What we're trying to do is we are trying to put Q by itself. So we've got to get rid of Q. Now the issue right now with Q is you've got a Q in the numerator and you've got a Q in the denominator. And of course we've got this denominator P minus 3Q. So we've got to get rid of that first. So what I'm going to do is I'm going to bring it to the numerator on the opposite side next to the T, and I'm going to actually multiply it with t, and all of this is equal to 7p minus 6q. Now at this point I've got to expand the brackets, so I've got to do these two things multiplied by the t. So I'm going to get pt minus 3qt equals 7p minus 6q. Alright, so we're good with this so far. The next step that we want to do is we actually want to bring all the q's to the left hand side. So I'm going to leave the pt here, and I'm going to do this kind of slowly, but you guys will see what's happening. So I'm bringing the minus 6q across, which will now become plus 6q. All of this is equal to 7p. Now I want to get rid of the pt, so I've got minus 3qt plus 6q equals 7p, but because it was positive on the other side, on this side it's going to become minus. So we've got 7p minus pt. Cool. Next, we've actually got q as a common factor. So we're going to take out the q out, and we're left with negative 3t plus 6 equals 7p minus pt. So at this point I can actually get rid of the minus 3t plus 6, and that's going to get divided by, and so we're going to get minus 3t plus 6. And I think that's pretty much how you write it. It doesn't matter whether you write pt or tp, and it doesn't matter in the denominator if you have negative 3t plus 6 or 6 minus 3t. It really doesn't matter. But one of the things that we do with algebra is that we do write letters in alphabetical order. So if you see you know, AC, you wouldn't write that as CA, you just write that as AC, because A in alphabetical order, A comes first. But again, it doesn't matter as long as your letters are there next to each other. This question is actually worth an excellence question, I believe. Yeah, it is. So getting to this last line is going to get you an excellence. Correctly doing up to this line is going to get you a merit. Or consistently collectors, or here. So it could be merit here. You could also get merit there. Left hand side, number 1. And this part right here is going to get you an achieved just by doing p minus 3q. Wow, really? Multiply left hand side, left numerator. Yeah, that gets you an achieved. Cool, so that's pretty much it for this question, guys.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.